So, good morning, one and all, and I welcome Sanjeev Kumar Yadav to the first technical session of the day 3 of Faculty Development Program on Deep Learning for Computer Vision. Welcome, sir.
Thank you, ma'am. Thanks a lot.
Yes. He has done PhD in computational neuroscience, titled Stochastic Modeling and Monte Carlo Simulation of Spiking Patterns in an Ensemble of Neurons from Jawaharlal Nehru University, New Delhi. MTech and BE are done from Dayalpar Educational Institute, Agra. Total teaching and research experience more than 21 years. Recipient of Distinguished Faculty Award by Researcher Award, various certificates of appreciation and award from industry for guiding mentoring student project, NVIDIA certificate. He has guided more than 12 MTech students and he is supervising PhD students too. Reviewer of SCI Journal and editor of book published by Springer. So welcome you to this session.
Thank you, ma'am. Thanks a lot to Madhu, ma'am. I am really very happy to see you. You are doing very good. Your
Thank you, sir. Thank
coordination
you.
and management is so nice. Now the credit of this success of this workshop will go to all of your team, like
Thank you,
Preeti
sir.
ma'am, like Sweta Rani ma'am, and overall Shivani ma'am. And without thanking to Dr. Dilkeshwar Pandey, sir, it cannot be started. Sir is the like a that mentor ki everybody has the solution of any kind of the problem. So I am once again thank you, Dr. Pandey sir, for inviting me. And it would be totally incomplete if I will not thank from bottom of my heart to our HOD sir, Dr. Bini Sharma sir. In his uh, visionary guidance, we all people are working over here, and this workshop. So once again, thank you to Dr. Vinay Sharma sir, Shivani ma'am. Thanks a lot. So now we can start our session. Yes, ma'am. Am I audible, Madhu ma'am?
Yes, sir.
Yes,
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 sir.
sir.
Now
Yes,
you
sir.
can
You're
start.
Okay.
audible. You can start this session.
Okay. So now I am going to share with my content. I think first of all, I should share my sorry, Windows. वाइट बोर्ड शेयर हो गया है, इसको स्टॉप करना पड़ेगा. I think this whiteboard has been shared now.
Yes, sir.
Okay.
Share your desktop, sir.
मैं सोच रहा हूँ डायरेक्ट उसी को शेयर कर दूँ.
So we can, yeah,
So now,
right.
is it visible my slides?
Yes, sir.
Okay, okay. Okay, so we should start with this. Now, is it sir full screen?
Yes, sir.
Okay, okay. Basically, the topic of this workshop is the deep learning and computer vision. So first of all, I would like to start with the like computer vision. So I start with the vision. If we ask what is vision actually, so if we go by the definition of dictionary, so there is especially in all English dictionary, it is written like it is a 6 by 6. If eyesight of the person is good, so they think of like that is vision. But what is happening? Why my slides are okay? Sir, my slides are visible to all of you.
Sir, your first page is visible, Anna, where you
Okay.
have written object recognition with deep learning. So after that
Okay.
page, if you
Okay. Okay. Okay.
navigate that, Anna, we will see
That's
totally.
fine. Okay. So point was the vision. In our dictionary, it is like a vision हिंदी में we call के दृष्टिकोण. What is your vision for your institute? What is your vision for your, say, like your country? What is your vision for your family? But especially in computer, this is a very old desire of the human being. They wanted to done everything smartly, intelligently by the machine. As we know, machine never tired, a machine never ask you about the salary, they will not go for the strike. Uh, if they are trained in a particular manner, they used to do the work continuously. So with the evolution of the artificial intelligence principles, and no doubt this deep learning is the subset of the artificial intelligence stream. So the point was that as we know, as a human being also, 80% of our interaction with the outside world is goes through the eyes. We understand more through the eyes. If our other sensories are, if say in case it is not working, like our ears are not working, nasals are not working, our taste bud is not working. Out of these, all three senses are not working, but our eyes are working. Then we are able to understand our environment efficiently. There will be a little bit problem when there is some kind of the smell, some kind of the sound, but ultimately 80% of our cognition, 80% of our brain information systems work with eyes. So with the extracting the information from the environment and understanding the appropriate meaning, this is what the one of the biggest challenge in front of our latest science. How to give that kind of the intelligence कि a robot or a machine can understand by viewing, by capturing the images or video, they can understand what is happening. So in this way, to understand what is happening, first of all, we have to understand what is there around. What is there around. Before that, we have to be capable of capture that information what is there around. So what happens by the time when we were able to make a camera, digital camera, so first stage we have cleared, we are able to capture things what is there around us. What is around us? So means we are able to capture. There is a picture. Out of that picture, as a human cognition, we were able to understand whether there is a picture of the fair, picture of the river, picture of the mountain. But when the AI comes in picture and with the say invention of the that neural network concept, we were able to put the learning of the machine at some extent. So machine were able to identify the environment also. So two step, one step, taking the picture, taking the video, that could happen with the this all invention of electronics and optics and combining all those sensor transducer, blah blah, by digitization, everything. So we all of know how the digital camera work, and they are able to capable to capture the picture as well as the videos. But what is there in that picture? For example, say if I have deployed the lot of these cameras around my house, and when I at the evening when I come back, I just wanted to know, okay, say there is a like Siri or any other assistant. Okay, tell me, is there anything was wrong? Now, to understand the what was wrong behind you in that environment, either you have to go through with the whole video. So if I can tell the machine, say wrong means something which was not desired, there was a quarrel, somebody tried to come into that space. So whatever we have given the intelligence, so analyzing that video, analyzing those pictures, if it is able to tell me, that machine tell me, okay, things what happened behind you like this one. For example, very say video mining or आजकल picture mining is a very popular word. Say I want to know the video of marriages in every part of the world, every culture, with whatever the available on the Google. I just want to make the query. Okay, please give me the information about the marriage video. So what would happen if these videos are being, I mean, saved with the name of the marriage? भले ही वहाँ पे if something is other thing is there. So definitely Google has done a lot of things far in past. Even like TensorFlow is totally the libraries of the Google which we are using. Colab and other things. Mostly my previous experts have been discussed with this one. So now it is clear कि we want to get it done. We want to know from the eyes of the machine. Eyes of the machine, we want to know what is happening. Actually, this question is very challenging, or probably it may take next 20 years or maybe 15 to, if, as like the hardware is coming with the advancement, software is coming with the advancement, we maybe may presume कि in the next 10 years, it would be able to happen कि machine can tell you कि what was the scene, what is the meaning of that the scene. But at present time, like evolution of any other technology, we are living in that era कि we are able to capture the picture, we are able to capture the like a video. Now we want to train the machine, let identify the object in a scene, in a video. Is there cycles, are there motors, are there pedestrian, are there any say some policeman, anything which we do by our cognition. So this is what कि object recognition with the say अब deep learning है तो deep learning is really when you go with the different kind of the literature, you will find कि deep learning all understand कि we can analyze, we can extract the information from our knowledge comes from the data, and it all things are known to us. And regarding the deep learning, there were a lot of confusion. Say this is again a one kind of the network, neural network. So how do we call them deep learning? So at last, key all of the scientific community and these all researchers became the to come to the generalization. Like Dr. Deepak Garg has discussed in very straight and flat key. If there are more than one layer, if there is more than one layer, hidden layer, let call it deep learning. There may be the layers, 100 layer, 1000 layers. That is your model. Say either I am very poor key. If I am designing a some network, neural network of 10 layers, if somebody is doing the more faster, more accurate by only the 3 layers, so definitely that person is more smart and has designed some neural network with the more efficiency. So this is what quest it happens. This is only the quest which we are facing. How to make it more efficient? How to make it more fast? So we came with the lot of technical terms and like lot of neural network. So we will discuss one by one. Okay, so let's start. This is a big question with in front of the deck is stacked against developer. uh, since we are academicians, we can understand machine learning or taught by academics for academicians. That's why most material is so dry and math heavy. If we go with the say like a research paper, IEEE transaction, or in any reputed research paper, you would find key things have been discussed so highly mathematics, but developers need to know what works and how to use it, because they are more focusing on whatever the technology available and make the product. And it is really very important ki we technology, science, innovation is continuously evolving. So we cannot wait for that absolute technology will come, then we will make a product. But we can, on other way, we cannot stop to make more and more research, more and more understanding of the concept on the mathematical level. So these both things are desired. So that's why, as in my, I was listening all the previous lectures. So I have seen ki some of the lectures were totally, it became the more highly mathematical. So they know ki what is happening in the back end. Say when I call a through the API, you call a library. If I am say, I don't know ki how is it happen. My screens goes okay. So somebody is making on spotlight. Hello, what is happening? Why am I okay? So developer need to know what works and how to use it. So you will find ki, some of the people are very smart. Okay, no, start with the Kera, start with the Panda, Anaconda. Now I am initializing these libraries and doing this one and training my this network. And some after sometimes you would be like ki some pilot officer, some say captain is flying the jet. He is very skilled. He know what button to press at what time, but he is not aware ki what is happening the backside. So this is a two different domain, and at present I feel ki all of the academicians has to have the academician have to be very balanced. We have to be know proper about the that understanding of the techniques as well as implementation part also. So I try to make it a balance of both of the things. So we will let go by this one. So let start with image classification. Say uh, before going with the computer vision, there is a one intermediate task also. There was a one intermediate task. Say once you capture a picture, you capture a video, and the target of this lecture is to detect those objects in that video. But in between, there is one more thing. Ki before that, we could classify. For example, okay, we have captured a picture of lot of objects, and we were able to make those algorithm of neural net, software vector machine, whatever. They were able to classify. Say these there are some object, those are dogs. There are some object cats. Yeah, there are apples or bananas. Means at or if it is not labeled, we don't know this is a picture from some unknown place, or even there may be some objects that we have never seen. We don't given the name also, no labeling. In that case also, we have developed those algorithms, those can classify based on their feature and automatic feature detection. And so that was the intermediate stage, and sometimes it has been taught in image processing, became so intelligent image processing like this one. Whereas object localization involves drawing a bounding box around one or more objects in an image. This is the prior stage of detecting an object. We see this thing every day in our life. Either we are taking the picture from our digital camera, our mobile. We must have seen if there are people or there is a picture in there, so that software automatically make a rectangular box at the face of people, at the face of say picture. So this is what we are localizing that object. What is there in this? So we make a box around that object and we localize it. After that, object detection is localization can be done. Say, if there is in a picture, say in the cars, there are some say trains, there are some another uh, vehicle. These three vehicles are having the different attributes, different type of structure. So we can make by classification, by using the classification technique. If once we are able to classify the same kind of the object in that picture or video, then it only becomes the making that box around that object. So that called the localization. But object detection, अब localization में it may be कि many times it is not sure कि आप देखते होंगे कि when we took the images कि that box started to create around the many kind of the objects, but they are not faces. So object detection is more challenging and combines these two tasks and draw a bounding box around each object. Up now that box which we are generating or creating around the object, if it is intelligent in that sense key, uh, they are making the box with the green boundary, red boundary, blue boundary, yellow boundary. So we step up one step up advance. Initially we were simply making the box, we were able to make the box with the classification of the objects, with the identification object. Now we want to identify the different kind of objects. Say in that picture, say if there are n number of the objects, and say as a human cognition, I am sitting there in my room, and I am seeing the lot of objects are there, and I am able to identify each and every object. So the same thing, if that boxing can be done specifically according that particular kind of the, say there are two chairs. So if there are two chairs, that boxing is shown by the blue color. If there one table, that box is by yellow color. That if it is a one television, by boxing by another. And this is what it is all that comes in the object detection. And deep learning, how deep learning is going to help us, and how, so we will come across this one. So we can became the more formal about object recognition is referred to collection of related tasks for identifying objects in photographs and videos, what I have been discussed. Regional based convolutional neural network, RCNN. First of all, I feel before going with the hands-on with the example, I just want to introduce how this object detection became the possible when we came with the one special kind of the networks. Those were convolutional networks, neural networks. If people are doing the research and people have studied the subject or people has gone through, they must be agree with my point. Before this RCNN, SVM were taking the over. SVM has taken the place in place of RCNN. Software vector machine was more popular and more accurate before this regional based convolution neural network. So because being the convolutional neural network, it makes again the simplicity of selecting the size of the neural layers, and regional, that makes possible to applying the different reason based convolutional neural network in a same application, while matching with the training for the different type of objects. There is a one very famous thing is YOLO is again a very famous, is the second family of the techniques for object recognition designed for speed and real time use. It is getting popular at present. Okay. Again, user factors. So I try to make it more clear. Object recognition in the general term to describe collection of the related computer vision tasks that involve identify object digital photographs. Okay. So, overview of object recognition in computer vision task, we can say by image classification. Image classification, I told you, if it is able to classify the same type of object, algorithm produce a list of object categories present in the image, different category. Single object localization means algorithm produce a list of object categories present in the along with the an axis aligned bounding box. This is what the success of our CNN, indicating the position and scale of an instance of each object category. So that makes smarter computer vision. Computer object detection. Okay. Please don't get confused by first thing is very much clear. Image classification means in a picture, in a video, we are able to categorize the object based on their attribute, based on their property. But we don't know कि वो क्या है. right? Second, single object localization. After that, based on its position or a scale, say if there are cycles may be the different size. Initially, what we did, we are able to classify there are n number, there are 2 or 3 cycle in picture because of its on attributes and shape and size. But now the next step is this: if there are 3 cycles or different size in a picture, and we want to generate the that local box, right? जो हम पिक्चर लेते हैं, when we take the picture from the digital camera or our say mobile, so we see कि either any size of the object, either a small boy, big boy, a big statue of the human being, but that algorithm is able to make a box easily. It sounds very easy for a human being कहेंगे क्या फर्क पड़ता है, they what's the great thing, sir, give me the picture, I can draw. But think about those people who have worked with these algorithms, they understand the complexity of this thing. कि once all they are the one kind of the object with the different size at the different position and visible with the some little with the different angles. So how to produce that box around that one is a again very challenging task, but it has been done. So that was the single object localization. Object detection. अब अगला काम आ गया. So now we want to detect it. So let's say अब now say if there is a cycle, so it should be written over there either cycle or somewhere else. So in that case, it is started by the pure supervised type of things. Ki we have to have annotation, we have to have labeling of those particular kind of the objects in our database, in our that data. So whenever you see whomsoever has worked with those techniques, if you go by any data, I mean any data site, any data repository, when we took the picture from there, most of the smart repository give you the 2 folders, 2 things. One is the picture labeled by a particular string, labeled by a particular variable, and another is annotations where labeled by the same string we have rest of informations. Say if I go in more in an advance key, it is okay, my algorithm is able to identify there are 3 cycles. Go far beyond it. Okay, what are those 3 cycles? Is it Mercedes cycles, BMW cycles, Hero cycle, Atlas cycle? So in what happened in that case, we have to have that data bank. So that data bank, that data store will come with the additional information, or that information comes in another folder. This is what those who have worked and they must be familiar with this. Okay, let's take one very simple example. Say for example, here in this picture, this the ground truth is this one. Key steel drum is there, but now it is taking only one steel drum. This folding chair, loudspeakers, Persian cat, and so this is what key going into the object detection. So after classification of the image, we need to object localization. If we are able to localize the object, then we are able to by to tell it ki by approximate precision, say this particular object is belonging to a particular class, yeah, particular say type of the object. This one. Okay. So outline of this will be like object detection, convolution neural networks, region-based convolution networks, RCNNs. Image classification, I am just going with the fast OK class, task assigned correct class, label to whole image. This is digital classification, object recognition. And let's see classification versus detection. What I said, this is a pictorial representation. Here it is just classifying that there are 2 these pictures belongings to a category, their dog. Now it is doing the local. Okay, so these are detecting कि हाँ ये particular. Further we can go for the detection. Oh, for which breed this belongs, कौन सा dog है? There are number of breeds. So further we have to work on that defined algorithm. Problem formulations. Say we have this input and we what we need output is this कि we should get say अगर बहुत अच्छा है कि say I am taking the picture by a camera वहीं पे आ जाए कि लो okay this is the motorbike, this is a particular person, right? So this is what object detection. Evaluating a detector. Now this is again say detecting an image, detecting an object from an image, one part. So that algorithm which has been made for the detection, that may be evaluated with the performance matrices and measurements. Okay, test image है previously unseen है ये say in previous example we have trained our neural network with this data and it is very well it is able to detect and classify, and now we are giving this like test image. So by this test image what is happening, it is say there is orange color of the black box localization, it is detecting as a person detector prediction. So here with the approximate precision 0.9, it is by 0.6, as well as it is with the 0.2. इसको भी I don't know, it is like a fairy tale type of children's, as I remember from my childhood. Ki when we see the clouds and we were able to see a lot of pictures. I don't, that was a projection of our mind. हमारे पेरेंट्स को नहीं दिखती थी बट आई एम डेफिनेटली रिमेम्बरिंग कि आई यूज टू कॉल कि ओ वो बादल में ये वाला शेप बनना है. So that kind of things may happen. It is not there, but we are seeing over there. Same thing can happen with our algorithms also. With the 2.2 uh, approximate precision, it is showing over here as a person, but it is not a person. A ground truth person boxes, जो actual में जो persons के boxes हैं देखिए, one person is here, one person is here, one person is here, one person is here. There are 1, 2, 3, 4, 5 persons there, and this algorithm, whatever the this example has been taken from algorithm, it is able to identify 1, 2, and 3. 3. This is exactly 0.9%, 0.9 or 90%, we can say approximate precision. The 60% is a zero point 0.2, and rest of things could not be understood by this one. So evaluation of these detector is again a inherited part of detecting the objects with the deep learning. It is not only we can stand like any other algorithm. Say it is, I have shown it for some few examples. It is working and we cannot leave that one. Okay. Short by confidence, zero point 0.9, true positive. This is 0.8, 0.6, 0.5. This is a 0.2, false positive. All these wrong. This is again, I don't know how it is. Probably this, okay. Okay. Very good. So let's see if somebody can see. This may be the head of a person. This like looks like the hairs and there's a neck and there's a soldier. So this is this may be the mistake. Say dark may, if some people are seeing the from far away, they may understand like the some big statue of a person, but that is tree. Okay, so these are the evaluation matrix. We evaluate by the precision. Evaluation matrix, this is again those based on the their confidence and approximate precision. We have designed pedestrian is over there, and let's see A, B, C, D, E, F, G. These are the pictures and process pictures and different algorithm, average gradient or say max positive SVM, negative SBM, test image, RHOG descriptor, RHOG. These all are working. More sophisticated method, approximate precision is 90%, like this one. And why did it work? Generic categories. Okay, so I will. This is the quiz time. Say, this is the image, and let's say after processing that image, it is coming over here. So let's see. Yeah, this image belongs to pedestrian. This image belongs to pedestrian. Say, okay, this is understood. Either we can say pedestrian or a person is standing over there, and a little harder, definitely. This image is a little harder, and hint maybe like either it is airplane, bicycle, bus, car, cat, chair, cow, dog, dining table. But actually, it is bicycle. If somebody will see with very much, I am talking about the human cognition, and that human cognition is required to train by the machine. Let's see. These are two. You are able to the wheels. You are able to see like a chair. That rest of the structure of the chair. Pascal. Please don't get confused. Pascal is the that accepted database. इंटरनेट पे मिल जाएगा आपको Pascal data store. Actually, what happens? Very interesting thing. Those new peoples are those who have joined this workshop. Some people may think, sir, what's the big challenge? Why to take the picture from the say internet or so called the Pascal data to test our algorithm? Say I will go to the market, I will take there are a lot of cycles, go to the schools, people are moving with the cycle. I can take the picture with the different in the different light intensity and different situation with a different angle. So why can I not use those pictures to train or to make our algorithm? So it is just for those new people, those are recently emerged in the research. Please try to understand. Say you have taken your local pictures of say some cycles or anything else, and you gone through with the some development of the algorithm, some kind of the you suggested algorithm, and you started to claim, okay, my algorithm is 100% accuracy, and I have taken this data set. What would happen? अब now thing is required कि rest of the world, अब बाकी पूरी दुनिया rest of the world अब आपके डेटा पे they should practice their algorithm, then it would be authenticated कि हाँ it can be compared. It is very common thing. Say if the same input, if we are using globally using the same input, and with that input we are performing the operation, say proposing some new algorithm, proposing some new ideas, and we are able to demonstrate experimentally, analytically, mathematically, say okay, we have achieved this one. So there will be no problem for this rest of the whole say reviewer committee, scientist community to accept it. But if you say, okay, I have taken my own data, you would be surprised ki, those people who study the image processing, there is a girl with the head that you will find in most of the image processing books. One day my colleague, Professor Ankur Bharadwaj was talking ki, whenever it comes about the image processing, detection object, wo dog or cats start to be. It is not only those dog cat. It is a say it is a one common database, one common data where you are welcome to use it. You are welcome to use it and demonstrate. We are welcome to use it and demonstrate the reason. Then it can talk key whatever the previous algorithm have been worked and on that image. Then we can compare. Na? Otherwise, say I have taken my own data repository and self-claimed my algorithm is working so fast and all these things. So people will not believe on that, right? So that's why before my session, a lot of really this workshop is really good in that sense ki, before this ki, everybody was most of the people were having the complaint कि we don't have the data, we don't have the data. मतलब it was the if I go 3 or 4 year or 5 year back कि at the many of the places this was the general complaint. But now, as the global sharing of the knowledge, these kind of the peoples, a lot of peoples are working on they went and they digged, they explored. So now there is no problem about the data. A lot of data sites have been shared. So point is this key bicycle by Pascal. तो Pascal का वो data है little harder, white blob and green background sheep. This is a picture of the Shaun the sheep. Shaun the sheep is the serial. वो बच्चों का एक comedy है. It is about dog and all this. So now point is this key. This is what some history. How rapid performance improvement goes by 17%, 23%, 28%, 41%. This is the whole journey. And where we will stop, we can see the fiction, Hollywood fiction movies probably over there. Regional ways, this is what RCNN. RCNN, maybe somebody had must we discuss about this thing. But whenever we will talk about the object detection with deep learning, it cannot be ignored. We cannot ignore the RCNN. Right? Regional based convolution neural network is the foundation backbone of all algorithms, all kind of the applications where we go by this. So this is showing इससे पहले जो कुछ होता रहा, now we just see 53%, 62%. It started to leave behind all those previous. I'm getting the disturbance. Can anybody tell me, please? I will request these all my coordinators, please mute the fellow जिसका वहाँ से microphones. Okay, thank you, sir. Thank you, thank you. So now, I could give you that idea कि before going to the implementation of the object detection algorithm and all those, कि how this RCNN, I promised in earlier कि I would not make it more highly heavy as a mathematical or not like only working on the command prompt giving this and this and that ये आ गया picture ये data आ गया वो आ गया and it was not. So convolutional neural networks, it is important to understand कि ये बहुत important as a मतलब ये this page will make you very very much clear about कि why convolution neural networks are important in detecting the image, object detection, how they make a revolution in this industry or in this science. A convolution neural network is a type of artificial neural network, definitely. Image recognition, please try to understand. We are saying image recognition. And processing that is optimized to process pixel data. These two things that makes, I mean, previous, what I show you previous graph, where we have seen the rise of accuracy when we introduced with the CNN or RCNN. I would like to call it RCNN. So first of all, we have to know convolution neural network are the fundamental and basic building block for computer vision task image segmentation. Image segmentation तक तो CNN बार good very good. Fundamental and basic building blocks. So why these are the three-man layer, convolution layer? This layer helps to abstract the input image. You try to understand. Abstract the input image as a feature map by a use of filters and kernels. I would like to give you the idea. Probably those people who are working already must be knowing, but जो भी new है, convolution layer करती क्या है? मतलब say we talk in a very common language. Say image is coming. In that image, objects with the different shape, different size, different intensity of the colors, different grayscale level will be there. So if we want to work with the machine key, it is able to understand all the object clearly, explicitly. So what is there? Abstract the input image. Input image का abstraction करता. First abstract it. Go with those essential features and extract those essential features that can define that inputs equally well. क्यों करते हैं? Oh, we will face this problem when we train a network, neural network, because that input size becomes so huge and that makes our process very slow. Feature map, and we call it feature map. मतलब say if I want to talk about the chair की picture की वजह say if somebody told you for 4 lakhs legs height is say height is 18 inch or 24 inch height and base is of 25 square centimeter 25 square inches and back of this one you simply abstracted it. इसको abstract किया now you can work on with very fastly on numeric value and all those things because कि जो image है that is like uh, something which is analogous and it is not in terms of the numerical value. Digital image comes with numerical value, but those numerical values are further required to be abstracted. So, because we know okay, overhead of the neural networks, we already understand the neural network, when we increase the layer, it takes a lot of time to train it and to make it more faster, more efficient. So, input image as a feature map, use of filters and kernels, must be knowing. Pooling layer, this layer help down sample feature. देखिए, this is again written, down sample features. वो फीचर्स अगर उन फीचर्स से दोबारा ऑब्जेक्ट बनाया जो कि आई वाज डिस्कसिंग ऑन दो प्रीवियस पिक्चर्स वो साइकिल आपको नहीं दिख रही है वो जो प्रीवियस पिक्चर में क्विज में कर बाइस्किल पास्कल आपको नहीं दिख रही है बट दिस न्यूरल नेटवर्क इज अंडरस्टैंडिंग द साइकिल बाय ओनली दैट मच इंफॉर्मेशन दैट इज इनफ फॉर दैट कि उसके लिए इतना काफ़ी है कि दैट पैटर्न ऑफ पिक्सेल्स एंड ऑल दोस थिंग्स though it can classify it as a cycle. So this layer helps to downsample feature maps, summarizing the presence of feature and patches of the feature. Fully connected layer connects every neuron in one layer to every neuron in another layer. We are very familiar with this type of the structure of neural network. Combining the layers of CNN enables the design neural network to learn. जब सारी लेयर्स को हमने कंबाइन किया कन्वोल्यूट करना शुरू करेंगे विद द वन लेयर टू अनदर लेयर आई विल हाउ टू आइडेंटिफाई एंड रिकॉग्नाइज द ऑब्जेक्ट ऑफ इंटरेस्ट इन एन इमेज सिंपल कन्वोल्यूशन न्यूरल नेटवर्क्स आर बिल्ट फॉर इमेज क्लासिफिकेशन and image detection with a single object in the image. Please everybody I would emphasize over here जो लोग सुन रहे हैं really I would emphasize here कई बार ये उसमें ही पूछा जाता है इंटरव्यू वगैरह में भी कन्वोल्यूशनल न्यूरल नेटवर्क्स वर फॉर इमेज क्लासिफिकेशन के लिए बहुत अच्छे काम करते हैं इमेज प्रोसेसिंग में यू वुड गो you will find a very hefty big use of CNN. But when it comes about the object detection, it has been found if I want to detect a single object in image, then these are efficient. If we want to detect a single object on the way, then these are the efficient. Otherwise, these are these are poorer than the software support vector machine SVM. I will show you this one. Okay. So next, standard neural network. Everybody of us know these are the inputs. X1. This is the first layer of the neurons. Actually, ये भी the layer of the neurons है, but this is the input layer which is never counted. This is never counted in any computation. So, in spite of that saying the input layer neurons, this is the first layer. Then this output layer, we all of know xi, like we take the transpose of this one. Yeah, this is understood basic. From neural networks to convolutional neural net, local connectivity, shared weights, multiple feature map, pooling. वही summarize है जो इससे पहले I have discussed in depth. Okay, let's see. Convolution होगा कैसे? देखो कैसे होता है. Convolution neural network, local connectivity. Each green unit is only connected to 3 neighboring blue. Let's see. This unit केवल 3 से. This unit only with 3 neighboring. This unit with. Otherwise, as we have studied a neural network, जिन्होंने भी पढ़ा है. If I will not go with this minute detail, एकदम ये automatically सब बन जाता है कि okay, everything is connected with everyone. Normally, what we see. As here everything is each green unit is only connected to 3 neighboring blue units. Okay, this one 3, 3. So how the convolutional neuron shared tide weights, all green units share the same parameter W. अब ये क्या करते हैं कि से these W1, W2, W3 everybody knows weights हैं. कन्वोल्यूशन में क्या कर रहे हैं कि इन जनरल न्यूरल नेटवर्क में क्या होता है ना कि फुल्ली कनेक्टेड न्यूरल नेटवर्क में दिस न्यूरॉन मस्ट बी कनेक्टेड विद ईच एंड एवरी दिस लेयर न्यूरॉन्स सबसे. एंड इन दैट केस this W1, W2, W3 नहीं होता. How many connections are there? These all connections will have its own independent weights. So those would be like W1, W2, W3, W like this one. But in convolution, say if you recall by the normal convolution of the functions, अगर आप linear algebra से भी अगर if you will call it, then you will find the like that similarities. So these all these three, all green units share the same parameter. Each green units compute the same function but the different input window. मतलब यही जो न्यूरॉन है एक तरह से यहाँ पे भी वही न्यूरॉन है, वहाँ पे भी वही न्यूरॉन है, बट इनके बेट भी सेम. बट क्या हो रहा है, सिंपली इनपुट है डिफरेंट होगा, ये सब इनपुट इसको डिफरेंट मिल रहा है, राइट. So this is how this convolution network started to work. Like this one, you will see all green units share parameter. Each green unit computes this one different input window. I would be faster like this one. Let's see how this convolution is happening. Same that green neuron with the same weights and connecting at a time with the neurons from the inputs layer and like this one. But one more interesting thing, I want to just make it more very much clear. Why 3? Why not 3? Only 3. This one. This whole neural network deep learning is the part of the soft computing techniques. So there is no hard bound anything. I will share when we will implement it. Okay, so this is how this convolution start to work, and pooling happens. 2D input image goes there, and now like this convolution start here, right? This is what convolution. That green neuron is now convoluting, and what is done? It is makes that feature map, that image. देखा उसको they have extracted the image, and that image is further. The people of image processing can understand how this has been stored in the matrix. So this is good for one single object detection CNN. Okay, and this is the demo. Now this, I think time is not allowing. The fall of convolution network fall हो गया. Core idea of deep learning आ गया. SVM killed neural networks. I told you कि फिर now the person, this Ross, came with the new idea with the region CNN, regional CNN. वो जो CNN एक्चुअली उसमें अप्लाई हो रहा था, देखा था कि इनपुट लेयर में सारे न्यूरॉन्स हैं और उसमें वो कन्वोल्यूशन. इसमें क्या हुआ, लेट स्टार्ट विद द रीजन. से आई एम मेकिंग यूजिंग द वन CNN ओवर हियर, another CNN over here, another CNN over here. So regional CNN. So that works the idea in that way कि it becomes the more efficient, more fast to classify as well as the identify, detect the images. RCNN family में actually this Ross has written that paper of reason with CNN feature RCNN. फिर इसका बना fast RCNN, faster RCNN और masked RCNN. So I will just want to give the name of these one. Probably you will understand. Module 1 reason proposal. इसमें RPN भी आया, reason propositional network we came with this one. Generate and extract category of independent reason candidate bounding. Module 2 feature extractor, like you have seen in that picture कि वो feature extract किया और that feature extract करके उसको feature map से with low detail and classifier over there. So RCNN like this Alexa Neat. I was planning to discuss this, but I think fast RCNN. This fast RCNN में क्या हुआ कि same people with the Microsoft research team again this paper opens a review of limitations of RCNN training is a multi-stage pipeline. उसमें training was single stage. It was not pipeline in RCNN. Fast RCNN, it is the multi-stage pipeline, was the preparation and operation of 3 separate models. Remember, 3 separate models. Training is expensive in space and time, no doubt. टाइम ज़्यादा लगेगा. 3 डिफरेंट मॉडल्स हैं CNN के और डिफरेंट स्टेज पे हम यूज़ कर रहे हैं. एंड ऑब्जेक्ट डिटेक्शन इज स्लो, डेफिनेटली स्लो होगा बट प्रिसाइज ज़्यादा होगा. इट इज टेकिंग मोर टाइम, more memory, but giving the more precise answer. Fast SIN propose a single model. I will go by this one. Then faster CRN आया, इसने reason propositional network. Convolution neural network for proposing reason and type of object to consider in the reason became with this special modules reason proposal network. Just try to understand. पहला था reason regional CNN कि भाई रीजन वाइज हम उसको CNN अप्लाई करेंगे बट रीजन वाइज बट हु विल डिसाइड कि व्हाट रीजन शुड बी टेकन, विच रीजन, कौन सा रीजन लें that will make our my algorithm more faster and more precise. So faster RCNN was equipped with this one more regional proposal network. This is one more network, and then we use the fast R, the previous fast RCNN. So it is a combination of these two neural network that makes them faster. And they have 2016. The very interesting part is this. Whomsoever the faculty is participating here in this FDP, I just want to say to them, let's see. Many times we see the problem, research problem, we used to find कि कहाँ करें research, what is it? Let's see, this is the latest work. It is the work of 2016. And we are in 2021, it is only 4 year back. Otherwise, we have seen most of the people are working 50-year back papers, 20-year back papers, and they are doing. Okay, even the research is one thing which keeps on going. So, but this is what key latest point, and you can go by this original research paper. You can find the scopes of this one. Okay, mask CRNN ये all latest है. This is more useful with the जो videos हैं, because this is there are two main types of image segmentation, semantic segmentation and instance segmentation. Under the mask, I want to see the example like this one, semantic segmentations. When we will use this mask or CNN, so now it is able to identify, classify the picture. These are the persons, these are human being, it is has been classified. This is semantic segmentation. Instance segmentation, now it will show this is who, this is the like my friend 1, friend 2, friend 3. It is able to identify, like if you say, very good, say if we go by the group photographs of our childhood, say we are studying class 3rd and 4th and 5th. Say if I take the picture, after taking that picture, it is able to tell it, okay, this is the your that friend, childhood friend. So first it will identify the, okay, these are the boys or students, and the name of that is the instant segmentation comes in this one. Okay, advantage है, simplicity है, performance है. So you can understand जो mask R and RCNN है, this is more latest. So these go with their original research paper. I have those one, but I don't have the time to discuss by opening those research paper. You will definitely get a lot of number of good implementation problems. The reference I think to Jason Brownlee. I have taken the maximum content over here, and I want to be academic honest. This is the book, Deep Learning for Computer Vision, is a very good book. Now I comes to another part, that is the hands-on, because this will not be I will be feel the complete without discussing the hands-on idea with this one. Okay, I am stopping my this slide, and now I want to share another window, that window of um, आ गया भाई. Okay, so I think I have to first open it. Okay, let me open. I opened it in my window, and now I am going to share it with you people. Probably it should come here in listing. PDF आ रही है, PDF नहीं आ रही है क्यों? Okay, and sir, is it visible my this case study of anybody, please? Preeti ma'am, Pandey sir.
Sir, your folder
Oh,
is
it is not.
visible.
No, not visible. Na? Again. Now it would be. Now it would be. Now it's visible.
Yes, sir, it's visible now.
Okay. So this is the my implementation part. Honestly sharing, you will come to the part. I can open the spider. I can go for the code. But those who people have worked on this, really they know कि at the time of running those code, lot of things comes about the tuning, lot of comes about the syntax. Even मतलब downloading the data of say 800 MB, this will again take a lot of time. So what the whole work I have summarized with the code and all everything. So this is a case study object. It is cats and versus dogs. I just again want to say कि these are those cats and dogs data जिसपे कि whole of the word is working and they are comparing their algorithm. Objective is how to load and prepare photos of dogs and cats for modeling, how to develop convolutional neural network for photo classification detection from scratch to improve model performance, how to develop a model for photo classification detection using transfer learning. These things which I have, I will try to cover it over here. So I should go by the view of full screen mode. Now is it visible to everybody? Is it visible? Hello.
Yes, sir. Yes, sir.
Yes, sir.
Yes, visible. Uh, in this problem, of this complete task has been divided into 6 parts: dog versus cat prediction problem, data set preparation, develop a baseline. Please try to focus on develop a baseline CNN model. Then we will improve the performance. Develop a model improvements. Explore transfer learning, how to finalize a model and make predictions. This is very famous data set on Kaggle machine learning competition held in 2013. Actually, how this data set becomes the popular and anonymous and compulsory to use because say some very prestigious institute is making a competition. They are holding a competition and we people are going with our algorithm, our program, and we are going to show them that our algorithm is taking more less time. So what they will do, they will share the common data to everybody. So in 2013 की ये competition में Kaggle के पे ये data share हुआ था, everybody works, and that becomes a like data set preparation. So if I go next डेटा सेट प्रिपरेशन बिस्टिंग ये इसके अगर मैं लिंक पे जाऊंगा दिस इज कैगल कॉम डॉग्स वर्सेस कैट डेटा दिस इज अराउंड 800 MB 25,000 जेपीज पिक्चर्स हैं एंड मुझे लग रहा एरो की से ही चलना पड़ेगा ओके देन आई थिंक आई कैन मूव okay okay now so that could be download 800 megabyte ka data it will take time so I am presuming I have done it plot cat and dogs photos so this is the one okay before that I just want to share most of the people must be knowing there is a keras there is a theano or there is a tensorflow keras is that interface which makes our life simpler when we are going to use the library of Theano as well as TensorFlow. These two libraries are very popular. TensorFlow is from the Google product. And Keras makes things as simple just by using the APIs. We call all backend libraries from there. So this code is written in Kera. Plot dog photos from the dogs for this data. So this is a function where I am plotting these one, and this is coming like um, this was like pictures. This will be shown on your screen when we will run this one. These are the pictures. The point which as a developer, as a researcher, that will make the importance of Joe, that will be a problem for us. Let's see the picture of different size. इसका size अलग है, इसका size अलग है, इसका size अलग है. And the information, I mean this picture has been taken, इसमें dog का face prompt है. Here the open mouth face, this is the closed mouth face, the street dog sitting there in front of cat, and cat is again because our cognition we are understanding, or maybe I am wrong, it is maybe another dog, but I feel, and this is another dog face, this is the another kind of the dog, this is matching with this background. And let's see, this is a running dog, let's see, it is standing near to the some. And this is the dog is having the same colors as the this bat seat, and this is the dog. So this Kaggle data set having the around 25,000 pictures, they try to get it as more as possible information. So here we need to divide this data set first for the testing and for training also. So let's see, again, we can see these photos are all different sizes. We can see the photo of the landscape format, some are the portrait format, some are the square. Let it try to restrict the photo in say some common platform with the select standardized photo size. This is important for our neural net, our processing. We have to go to make it more efficient or more faster. So we have to take the input of the same size with the different attribute. So we decided to take the 200 by 200 pixel. And the thing is this, which I want to share. If we want to load all the images into memory, we can estimate that it would require about 16 GB of the RAM, and it will take. But probably we generally have the 8 GB RAM. That's why I decided to go by direct the implementation. So this is another code running. The example may take about few minutes to load all the images into memory and print the shape of the loaded data to confirm it was loaded correctly. Okay, so let's see. This is the couple of the photo we have taken. I just want to come to the point. Load and confirm from NumPy import load photos. You know we are using these functions. Pre-process photos into standard directories. Like okay, pre-process the photo into standard directory. So what we will make? There are two directory, one for test, one for train. 25% of images means around 6,250, total the 25,000 image. Uska 1/4. So we have taken for the test data, and it is labeled with the out of those cats are cats and dogs are dogs. Okay. So cats have been labeled as the cat and dogs have been dogs. And this rest of 75% data is to train our this deep neural network. I've seen. We can create dictionary directories in Python using make directory. We know this is a function used a loop to create the dog cat subdirectory for both. So this the code of that one is code. If we run, we can get that one. And next we can enumerate all images and data and copy them enumerated. enumerating, why it is enumerating is needed. If we will download the data, I am again saying, if we will download the data, then you will find they have been given the file name. I am enumeration in terms of the labeling. I am saying file name like it may be 6-digit number like 000016. So we can have 10 power 6 naming in decimal, matlab around 10 lakh. If images we can label by those numbers, and it becomes easy. Say, if I simply make a very small program, either of any language, either of any language, if you are computer C, C++, any, just you are picking a one file, one image, and you are just giving the name, renaming with the one, string of the number. So we have to enumerate this one with the number. So but the same number, मैंने बताया कि annotation का भी folder हो सकता है जहाँ पे we can have the detail about that particular image. So name along with the name, rest of things. So let's see this for seed, where what we are doing, we are picking the randomly picture, define ratio of the picture to use for validation. Ratio of pictures to use validation 0.25. Copy training dataset image into subdirectory like this one for file listed directory, and we using this loop, and we are enumerated. The complete code of example listed below and assumes to have these images like this one. Organize data set into useful structure. Okay, from was import make directory, from import list directory, and by this process we can, after running the example, you will have to new data set docs versus cats oblique directory, because की dog versus cat data set का जो नाम है वो Kaggle का है, you have downloaded it, so we are giving the new name. Developing a baseline CNN model, जो after pre-processing of that data download, data separation, data enumeration. Separation means 25% data for testing, 75% for data for training, and enumerating those file with the numbers. So how does it help? Whenever I want to access any file, I want to call it any file, then it will be simple for the procedure by assigning a variable to the name of the file. So now let come, if things have been done, all things very well, developing a baseline CNN model. Now what we are talking, developing a baseline CNN model. Now we will develop a very basic CNN model, and we'll see how much accuracy we are getting this one. BGG model is like a good starting with generalized architecture principle. BGG model, there are some ILSR VRC models. These are two previously proven some good convolutional neural network. Now we may come about the question. My most of the talk is for those are starting a beginner. Okay, why with this VCC model? Why this ILSR VRC model? This is a question. Why? So now come to the point. As in my previous slide, I have shown you the convolutional neural network structure of that one. So my first topic was that we are not going on that discussion how CNN model will be programmed, how CNN model will be, how many number of neurons. If we will stuck on that, so definitely developer or researcher will not go ahead. So what happens at the throughout globally level, once at the international famous platform, it has been validated and proved, like these two models, two CNN model, BGG model or ILS or VC model. Say, it is written over here if you can see. These are good starting point because they achieved top performance in 2014 competition because the modular structure of the architecture is easy to understand and implement. So you must have seen in previous talk is also. People will talk about the CNN or CNN, but it may be a separate talk key if somebody is making them from scratch. So what happened ki now we are getting that advantage ki some models are already trained, tested and trusted in various competitions. So we are taking those models and those models we will apply on the our data set. Like BGG model, a very deep convolution neural network, large scale image recognition, ये 2015 का ये binning model है, competition binning model. So we are taking them. Or in spite of that, we must not forget about the title, developing a baseline CNN model. So these are two are the CNN model. As in previous I mean slides and previous talk I talk means some time before I have said already, CNN are not too much good for detecting the objects when number of objects are higher number, if it is a big number, right? CNNs are only good if we are talking about the detecting one object. So choice over here to taking the CNN model, because key we are now taking the data set of cat and dog. Either we are going to say it is a dog or not a dog, it is a cat or not a cat. So the object which we are going to detect is a single object in that picture, whether it is a dog or a cat, right? So that's why these baseline CNN models have been taken. Now we will see. Okay, please wait. Develop. Each layer will use ReLU activation function. Now, point is this. Okay, what is the beauty of all these, say, Python environment? No doubt there are already build models over there, but they have given you the customization also. We have the customization facility in these site TensorFlow as well as the Ethno or YOLO, whatever these library. Until unless if these customization, if just we assume, agar if this customization is not allowed, then what will happen? It will be like some machine is there. If you put some any material over there, that making the one kind of the product. वो आती है machine एक raw material one kind of the product. So that kind of thing is not there. That's why people are making progress over there. They are adding their own contribution over there, and we are coming up with some new things. So point is ReLU activation function. Up now all of us know key we are having the different kind of activation function, right? Point is this key we have given the freedom to choose the network, convolution neural network. These are two very famous neural network, and to choose the neuron with a particular activation function. So there are 5 activation function is given. So we can select a particular activation function also, which are generally best practices. In this example, to make the more simplicity and to get the results of your choice earlier, we are just selecting those already well proven. We are not going to हम इससे ज़्यादा बैल प्रूवल वी विल गो बाई दिस एडिंग समथिंग. अभी बेस लाइन है तो एक्टिवेशन फंक्शन में वी आर नॉट डिस्कसिंग हियर की this not the part of discussion ki there are 10 activation function which activation should be apply select. But I tell you, the people though novice in the research area, they just go by this thing. Say in say Python, TensorFlow in a library, or in this say these competitions, these people have been used such type of activation function. So this is not the dead end of the road. In especially in research innovation, there is no dead end of the road. But till that day, the people could understand this one. You can also go by the study of the different kind of these activation function or mathematical function, how you can say improvise or you change, and what kind of things you can make the effect over there. That may be one problem of research, because these are the very young models. 2016 is a very starting time when we talk about the research, because sometimes or many times we work on those models, those things which have been evolved and they have been worked by 20 or 30 years back. So in that sense, these are good. Okay, so this is the model at convolution 2D. The model convolution 2D by this activation Relu kernel. This is what the syntax which has to be learned. uh, I can simply, I just want to share my personal experience, whether some of you people maybe agree with this or some of people not. But since being the academician, we are researcher, so as I told in my previous very first slide, ki we need to go in the depth of the concept also, or we need to work with the that with the implementation also. But as much as you will go with the implementation of like this using the TensorFlow, Theano, one thing we started to face कि इतना जो predefined syntax, say when we were taught the C language, on C language mein, why this is taught initially, when we use these very high level language, तब समझ में आता है कि प्रोग्रामिंग के कॉन्सेप्ट तो दोज कैन ओनली बी अंडरस्टैंड लाइक सी लैंग्वेज, बिकॉज की वो प्रीवियसली डिफाइंड उसमें क्या है, वो डेटा टाइप्स हैं, सम फंक्शंस हैं, सम प्रीप्रोसेसर्स हैं, द वे द सिंटैक्स इज रिटन ओनली दिस थिंग इज. बट most of the time we do not go by the use library use नहीं करते हैं, or we learn by this. But these things when you say model.add and I am calling it, so I must be known ki how it is been written. No doubt you will give you when we compile it, we get a chance of the like error and warning has been told us. But these are not very that kind of the fundamental conceptual जो C plus and Java में आप लोग हम लोग सीखते हैं. तो keeping in this mind, I just want to give you the one very good problem और लोग work करें. Say if one day if these library will be so heavily loaded, इतना ज़्यादा syntax when those cannot be even remember, say once you are working on one project, you migrate to another project and slowly you will forget about, but you will not forget about C, you will not forget about C plus, so you will not forget about the Java as you have been taught in your UG undergraduate courses. But say if you do not work for 1 month on these library, and you have to again see all these things. So let's develop some voice interactive. Say I am talking to that compiler, okay, okay, open those suggest those all library where I want to identify say object of like animals. These are the animals, object of animals, living pet, and that maybe in video and maybe the stable. So whenever we talk about these objects like जो livings हैं, तो जैसे I can talk about the dog की picture इतनी सारी क्यों है, क्योंकि when the people are taking the picture, they are not taking the static object. The living object, you are taking from this side, that side. उसको बिल्कुल से जो भी living है उसको हम frame में से we cannot make them tied into frame and we will take the that kind of the pictures. It does not happen in the real ground. So I can ask, okay, like Siri or Google Assistant type, some maybe there. Okay, I want to develop a project to identify these things. Such kind of the background would be there. Such kind of the attributes would be there. Such kind of the accuracy is required. Such kind of the fastness is required. So automatically by listening these things, the compiler should be so smart. It should start to suggest you. Okay, this is okay, sir, you may go by this one. This has been tested by these number of project earlier. These number of the success rate was there. And if you will make the amendment on, make the customization of this kind of thing, at it may will be like a top bound of this one, lower bound of this one. So this is one research problem I am giving, sharing with all people, but it will happen. Remember, natural language processing based compiler will come one day. We will only need to talk to and we will make our programs. Okay, anyway. So now below is the example of defined modules. Up now we have taken, okay, we have taken these two models, say BGG style models. The function can be customized to define different baselines model version of the model with, okay, no, with 1, 2 or 3 BGG style blocks. So this is what kind of the customization is allowed. So you see the 16 block, 32 block and 64 block को use करके we will solve the same problem. Okay, let's come to by this one. The problem is binary classification, dog है या नहीं है, और output layer with one node and a sigmoid activation will be used, and the model will be optimized using the binary cross entropy loss function. These are some things which I can give you the idea in short. Output layer, output neuron, we are using the sigmoid activation function. You can again, we can again arise a question mark, why this one? So you need to go with the literature. And cross entropy loss function. Entropy loss function means what? If the output is coming, say one output pattern is coming, and previous output pattern, next output pattern, there are a number of patterns, output patterns. So how would we identify what is the distance? I mean, what kind of degree of the difference over there? So what we do, we compute the entropy. Entropy is the measurement of uncertainty. Uncertainty, oh, उसमें particular data में या particular वो जो pattern है जो solution, how much? And चूंकि binary output है, whether it is giving you the dog or not a dog, cats or not a cat. So this is a binary cross entropy loss function to optimize this one. It can be called to prepare model as needed. For example, say this is the I mean syntax of this model, define model. This involves first defining an instance of the image data generator that will scale the pixel value in the range of 0 to 1. So now we are going, what we are going? We are going to abstract. We are going to generalize. You can say we are going to normalize of the say scale of the pixel between 0 to 1. And we know how we generalize. The maximum range is 255. And so if the maximum value can be 255, so divide everything by the 255. So at most answer will become 1, and every rest of numerator is always less than 255. So things would come 0 to 1. So it is well understood by the people. Next iteration need to be prepared for both the train and task data set. We can use flow from directory function. Okay, now the point will come. How would you know okay, this function is there in a particular library? Yeah, how would we know? So even libraries are very rich. They are having thousands of the function. So as much as people will be in practice, they can remember. Otherwise, the solution is that natural language processing base your compiler. Anyway, flow from directory function on the data generator, create one iterator for each of the train and test directories. We have already made the two directories, train and test. In train, the picture of dog and cat, test and picture of dog and cat. In test, 25%, 6,250 pictures. In train is the how many pictures is the rest of the, and these pictures has been collected randomly, right? It is not like to overcome with the any accidental, biasing. We must specify that the problem is a binary class. So class mode argument क्या होगा? Class mode. Class mode is the part, is the variable which we can customize when we call that library. So class mode may be binary, non-binary type. This one we can decide. Okay. Load the images with the size 200 by 200 pixels, as I told you. 200 by 200 size, क्योंकि it may be the different size of the pictures, but when we work with this deep neural network, then we need to make the uniformity of the image, and we have decided to make it 200 by 200 pixels via the target size argument. This is again a syntactic thing. Target size is a undefined variables where we can give the target size of 200 by 200. We will fix the batch size at 64. मतलब batch जो है block 1, block 2, block जो हम बेस लाइन का कन्वोल्यूशन न्यूरल नेटवर्क लिया है उसको हम 3 ब्लॉक्स को एक्सपेरिमेंट करेंगे. ब्लॉक विद द 16 साइज of batch, block 2 is the 32 batch size, block 3 is the 64 block size. Okay, so where is this one? Prepare iterators, train it, data gen flow from directory, data set dog versus cat जो हमने अभी भी data set बना के स्टोर किया था. train is the directory name. उसमें class mode क्या दिया जो which we can decide binary. batch size कितना दिया 64. target size the size of that picture 200 by 200. So this can only be remembered when we always I say again if it is in practice. We can then fit the model using the train iterator, train IT. Understand? We have to understand it. We can then fit the model using the train iterator and use the test iterator as a validation data set during training. Okay. The number of steps for the train and iterator is specified. This number batches of one epoch. This can be specified by the length of each iterator. The model will fit for 20 epoch. So epoch probably whomsoever has gone through the basic study of neural network, they have worked with the even theoretically with the pen paper if they have worked, so they understand epochs. Okay, so fit model history is the one variable, model fit generation, train it, step per epochs, and length. What is the length of the train data, right? Validation data test. But here I would say if you make a algorithm by step, write anything. So in these high level languages, everything got it hidden, but we are simply directly working with those functions where we are just passing these arguments. Once fit, the final model can be evaluated on data set directly and classification accurately reported. Like this model evaluated, generator, test it, test data, strap it, length, verbose 0, print like when this 3 decimal places with accuracy like 100%. Finally, we can create history collected during training stored in the history directory written from the call of fit generator. The history contains the model accuracy and loss for this one. Okay, end of people. Line plots of these measures over training epochs provide drilling. The figure then saved in the file. So we can discuss about the code. So this is the pi plot to subplot to pi plot title cross entropy. क्योंकि जो हम लॉस देखेंगे, एक्यूरेसी देखेंगे, वो हम किससे देखेंगे? cross entropy, binary cross entropy. So we are calling that function title में सिर्फ cross entropy लिखा होगा. When we will call it classification accuracy. This we call the complete examples of this one baseline. Okay, I would go by slowly and slowly. Cross entropy and this KRAS. Because this code has been implemented with Kera front end and this have one library also. Filterly import, category models import, security layers imports, convolutional 2D, max pooling 2D, dance flat import this one, or sequential model is this. So this is the code of that one where लेवल ट्रेन हिस्ट्री लॉस कलर ब्लू जो हम प्रिंट करेंगे, जो ट्रेन करने के बाद जो रिजल्ट आएगा. वन ब्लॉक बीजीजी मॉडल. एज आई अर्लियर टोल्ड यू, यहाँ पे we are going to use the 3 block, 1 block, 2 block or 3 block. The 1 block BG model is single convolutional pair, 32 filters followed by a max pooling pair. So number of filters as we are increasing, and we are saying there's 1 block, 2 block, 3 block. Twice of this, thrice of this, so we will call the. If filter is a 32, 1 block, 2 block filter is a 64, 3 block means filter is a 128. The define modules function for this model was defined in the previous section, but provided again below for completeness like this one. Same thing which has been already written, and this block dense 128. It means the third block, 3 block wala hai. Or running the example, and what happened ki ultimately the model is then fit and evaluated, which takes approximate 20 minutes on the modern GPU hardware. जनरली इतना लग जाता है. से मेरे लैपटॉप पे इट कैन वेरी. दैट्स व्हाई आई हैव मेड इट रेड. बहुत इंपॉर्टेंट बात कहनी है. और दिस इज नॉट ओनली एप्लीकेबल in my discussion, in my I mean, this my implementation. This is equally applicable with any kind of the learning, any kind of the training data. In this case, in one iteration means in one completing all one cycle with 20 epochs. So we found that 18,690 images belongs to class 2, 600 belongs to 2 classes. ये भी 2 classes को belong करती है, ये भी 2 classes. So this we found 72.331% is the accuracy. Your result may vary given the stochastic nature of the algorithm or evaluation procedure. Difference is numerical precision. देखो stochastic nature, since there is uncertainty what kind of there? The picture we are taking collecting of say dogs. So dogs की सारी pictures में देख रहे हो कि कोई similarity नहीं है. There is totally non-similar. And when we are going to measure the non-similarity based on some say variable means if you take the variable ki distance of the mouth from 0 0, I mean coordinate 0 0. So once you have taken the 100 picture, 1000 pictures, you will get okay distance 10 mm पे 500 dogs हैं, distance 20 mm पे 300 dogs है, distance like this पे इतना dogs है. But when we go by again and again collecting the data, so it goes under uncertainty. So stochastic nature तो है ये inherited है with the every kind of the say training or every kind of the neural network. So we have to understand. In the case we can see that the model achieved accuracy 72% on the test data, and this is a cross entropy. This is what classification efficiency है ना. 2 block BGG मॉडल में क्या होगा, जो कोड है उसमें 64 फिल्टर्स हो जाएंगे, रेस्ट ऑफ थिंग्स विल बी सेम. एंड 3 block BGG मॉडल में क्या होगा, the things would be 128, right? 128 filters हो जाएंगे, बाकी सब. Running this example, print the size of the train and data set, confirming that data set was loaded. Again, we can check the size of the data which has been loaded correctly or not, size of the each and every pictures. But in case now belonging to this big number and it is going to go to the 80.1.84% accuracy. Note that again the result may be vary because of this, and 80% accuracy 3 blocks. But this result is good as it is close to the prior state of the reported paper using SBM. पता है ना? बीच में neural network were overpowered by the SBM support vector machine, because we have already seen that उनकी accuracy 60% 65% तक रह गई थी. But again with these kind of amendment and changes, say I am changing the number of filters. So first 32 filter, then 64 filter, then 128 filter. So out of these, reviewing the plot of learning curves, let's discuss. We have explored 3 different models with a BGG baseline architecture. The result can be summarized below, like BGG1 में 72% accuracy, BGG2 में 76% accuracy, BGG3 पे कितना? This is how much accuracy? 80% accuracy. So this is clearly visible when we are changing the number of filter. Say I have taken the filter 16, 32 and 64. And we see the accuracy is increasing. Somebody may ask the question, very well question. Is this linear? Means accuracy is directly related to the number of filter. So sir, why you stopped at the 64 number of blocks? 64, filters. Who stopped you to take the 256 filters? So for gently, I want to say that these are the result which have been achieved. You don't know after how many iterations or how many tries. That's why in red, especially I would like to emphasize over here, whenever go by any neural network, at the same time, if I am running on my machine, at the same time somebody is running or there's some another machine and cloud, given the same type of the data. But guaranteed is this key, everybody will not get the same type of the accuracy. This is the inherited characteristic of stochasticity uncertainty, which have been dealt by any neural network, We do the approximation, we compromise the degree of precision. So definitely these things would become. We say we are using the different weight assigning techniques, or it may be as the by virtue. Sometimes some things has been started by the selecting some random quantity, random attribute, but it is a one optimistic. It is a one optimistic result. But please don't confuse. These CNNs are not purely in linear nature. It may happen when I did run this whole algorithm for say 16 filter, it may happen after doing the 1 or 2 iteration, I got this accuracy, and after that I go for more 100 accuracy. I did not get accuracy more than this. So we have taken this value. It again, so I think I am able to communicate my message. Don't think this has been achieved at a single glance. 72.33. I am sure if you will use this code, which have been used by me, you may get more accuracy of more than this one, because ki every time we has had to stop at some place. But say fortunately you got say those random attributes and those fine tuning parameters ki you may get it, or it may be you may not get it up to 1000 iteration also. So this is what key. This has been a study made by whatever the my I mean, limited resources, and I am showing you very optimistic and positive result. But you maybe get I mean irritated or get fed off key when you are started to use 128 filters and say your performance in terms of the time taken or accuracy. So that is say not coming near to this one. So please remember, if we are able to compromise on the say whatever the time would be taken say by training the network, we don't, it doesn't affect us, whatever the memory is required doesn't affect us, then we may have that liberty. But in computing world, none of us can wait for the infinite time for our result. It is the very basic things which has been taught by the Coreman. Whenever we study the algorithm, then it comes a good characteristic of algorithm. Then at that time, Coreman has discussed very smartly. He started from beginning. What are the characteristics of good? It should be terminate within a. It should be terminate within a limited time. So we cannot allow. We cannot allow. In spite of that, you are having lot of time. कोई जरूरत नहीं है. एक दिन, दो दिन, 50 दिन, 100 दिन. तो लिनियर तो है नहीं कि 100 दिन चलाने के बाद अच्छा ही मिल जाएगा, राइट? तो रिजल्ट सजेस्ट दैट द मॉडल विल लाइकली टू बेनिफिट फ्रॉम रेगुलराइजेशन टेक्निक्स, ओके, वर्क फॉर मॉडल इंप्रूवमेंट्स. अब नाउ लेट्स सी डिस्कस फाइन ट्यूनिंग. अब हमें जो 72 तक आ गई है एक्यूरेसी, अब हमने ये तो डिसाइड कर लिया, वी हैव डिसाइडेड कि ओके वी विल गो फॉर थ्री ब्लॉक 1, ब्लॉक 2, ब्लॉक 3. There in block 1 we will use the 16 filter, block 2 we will use the 32 filters, block 3 we will use the 64 filters. But this thing is regular is happened. Now let's go by the some another more regularization, that is called one dropout regularization and data augmentation. एकदम माइंड में पॉजिटिव एकदम वेव्स आती है, स्पेशली डेटा ऑग्यूमेंटेशन सुन के. तो whomsoever has come from computer science background and has gone to study with the data structure and algorithm, at that time they have studied about the augmentation, and they have been told that every augmentation is going to improve the result. Again I am showing you optimistic picture of the whole scenario. I am not discussing with the pessimistic picture, but for our understanding, for our knowledge, for our preparation, we should be ready. Every time data augmentation is not going to give, every data augmentation is not going to give you the good result. There is possibility if I augmented the data, that may give you, for example, I have taken the picture, most of the picture is taken from a particular angle. If I just augmented the little bit position of those pixels of each and every image में से कुछ pictures की उसका spatial shape थोड़ी जो space में वो हमने change कर दी. For example, if I am to working with the video के लिए तो ये CNN बिल्कुल नहीं है, ठीक है. So if I am working for the video, so I can say okay, I have worked on the video from this angle. Okay, let's work on some different angles. Take the video from you are for the same scene. Why scene? एक घोड़ा, say one horse is running. Some people are running on the horses. Some people running on the bikes. Say you have shoot that video from different angle, and when those videos would be passed the input to any, I mean deep learning architect neural network, that means we are giving augmented data, that is data has been changed. And dropout regularization बहुत अच्छा है कि ड्रॉप आउट रेगुलराइजेशन, जैसे कि इसका नाम है कि कुछ ड्रॉप आउट कर रहे हैं, ओके. For example, I just want to give you an example of one movie, one kind of situation. Say you are bringing a lot of gold. You have a sack of gold of 10 kg. Because of that 10 kg, we have a particular speed, right? Particular speed means, say what we can assume any, yeah, we can say for sake of the 100 kg gold है 100 kg है, किसी को भी मिलेगा. अगर वो 20 kg का भी है, he will try to carry on. But the condition is this कि
Hello.
you have to, hello,
Excuse me, sir. Sorry to
yes,
interrupt.
okay ma'am.
Sir,
Time हो गया.
3 minutes more. So can we have the question answer round now?
Yes, we can have question. Otherwise, I have shared my say mail ID. That is sanjeev.yadav@kite.edu. So anybody can discuss with me at any time. क्योंकि I believe कि this is the topic where because of its nature, na, whenever we will try to cover as a whole, it requires a time. Even I believe कि I could not say. So I will take 1 minute. So I was talking about the dropout. 1 minute, ma'am. Okay, huh? Would you allow me for 1 minute?
Yes, sir. Sure.
Thanks a lot, ma'am. I know you have very good kind heart, big heart. Anyway, so point is this कि dropout के जो concept था, just try to understand. One person is coming with the 100 kg of the gold, but it is a restriction कि within 10 minutes he has to reach to that gate. If he will cross that gate, then whole 100 kg gold is yours. If you will not reach by 10 minutes to that gate, you will die. Even none of things will be, क्योंकि उतनी देर में लुटेरे say robbers are going to come, yeah, anything which have been game rule of the game, whatever things, but within 10 minutes you reach to Gurdev. So what would you do? We will drop out something. देखा स्पीड बढ़ाने के लिए वहां से 1 minute is left and I cannot run fast because of this weight. So what we will do, we will drop out something. So as we will drop out, we will increase our. So same thing, very interesting. Same thing happens here. We will drop some, say some connections of the neuron. We can drop some inputs. So we this is one other kind of the augmentation, but augmentation with not with data. It is augmentation with process. So that's why these two things are especially discussed over augmentation of data and dropout. क्योंकि one common thing is this कि add on करने की तो nature है ही है कि okay. So okay ma'am, thank you very much. Madhu ma'am, thanks a lot.
Yes, sir. So I request the participants to please raise hand if they have any query.
Okay, so I think we can connect by the our email ID. Or things that may again started to explain. And
Okay, Gaurav sir, you have the mic. If you want to ask anything, please, sir. Gaurav sir. Okay, so we will provide you the email ID of sir. If anybody have any query, you can contact to sir. Okay, Shri Lakshmi ma'am.
Lady itself.
Yes, ma'am. Yes,
My
ma'am.
lady itself.
Lakshmi ma'am, do you want to ask something?
Sir, ma'am, I want to ask the mail ID only, ma'am.
Pardon, ma'am?
Mail ID, mail ID. Mail ID, ma'am. Am I audible?
actually she is
Yes,
saying
ma'am.
she want email ID.
Yes, sir.
So you have written that one. That was the query actually. Okay, ma'am. So nice. I would be really happy. It would be my pleasure, and I want to share one thing with all my audience. Whenever you will send a query, na, that may be the one root of one research paper also. If you will go to dig that query, that may come about the one kind of the problem that can be converted to the research paper also. Okay, so it is welcomed.
Okay, thank you very much, sir, for sharing your deep knowledge and providing hands-on object detection for computer vision. Thank you very much, sir. It's a
Thanks,
really a
ma'am.
good session, knowledgeable session.